Okay, on number 13, it says identify all whole numbers in the set below. So you'll notice I went ahead and noted for you guys. It says for the test, you'll need to know the whole number set. And remember, your whole number set is just all natural numbers and also 0. So when you look at your whole number set, you're looking at 0, 1, 2, 3, 4, 5, so on and so forth. And then the set M is 1, 2, 3, 4, 5. So that is your natural number set. You'll need to remember your natural number set. And also you'll need to remember your integers. So integers are all natural numbers and they're opposites. So like -3, -2, -1, 0, 1, 2, 3, and notice the 3 dots means it goes on forever. So when you look at your sets, you have to identify the numbers that either reduce to be a whole number or are already a whole number. So as I look at my set right here, you're going to notice the whole number set. Well, 3 is a whole number. -5, that's not a whole number, that's going to be an integer. Square root of 5, well, that is irrational. 0.25, that's irrational. Pi, irrational. 2/3 is a fraction, it's not a whole number. And then the last one, 0, well, that's also your other whole number. So your two whole numbers that are from that set is a -3 and 0. Okay, number 14, just have to remember laws of exponents. So on number 14, it says to simplify exponents, you go ahead and combine the numbers and exponents separately. And remember your laws of exponents. So just kind of a reminder on your laws of exponents. First law says that if I'm multiplying, so b to the m times b to the n, you just take your two exponents and add them together. And then the other rule that you also need to remember is if you're dividing, if you have b to the m all over b to the n, you subtract your exponents. So that is b to the m minus n. And then your last law that you need to remember is dealing with your negative exponents. So remember, if you have a negative exponent, to get rid of that negative exponent, you put it in the denominator if it's in the numerator. And then if it's in the numerator, you move it up to the denominator. That's how you get rid of negative exponents. So as we took a look at this in this set of problems right here, that's what we're going to be doing. So you're going to notice that, first off, we have a 13. Looking at our numbers. Remember there's a 1 there. You don't really have to multiply by 1, so I didn't write it down there. And then there's also an 11. So you're just going to take your calculator. I'm just going to go ahead and take 13 times 11. So take your calculator, type in 13 times 11, doing your numbers separately, and you get an answer of 143. Okay, now I'm going to take a look at my variables. I got x to the 8th, I've got x to the 5th, I've got x to the 7th. So writing those out separately, I've got x to the 8th times x to the 5th times x to the 7th. So remember, our rule says you're going to go ahead and add all those numbers together. Because remember what exponents actually are representing when I'm using them with my variables. This actually means right here, I've got 8 x's, I've got 5 x's being multiplied, and I've got 7 x's being multiplied. So you're going to notice if you actually add those together, you got 8 plus 5 is 13, and 13 plus 7 is going to be 20. Now you've got 20 x's being multiplied together. So therefore your answer is going to be 143 x to the 20th. Now in this next problem right here, it says that we're going to have 2x all over 4x and -4. So you're going to treat your numbers and your variables separately. So I got 2/4. I'm going to write that out separately because 2/4 is going to reduce down to 1/2. Now notice on this one right here, this is x to the first. So my rule states that if I'm looking at dividing, I'm going to subtract the exponents. So this becomes x to the 1 minus a -4. Well, of course, a minus makes that a plus. So 1 plus 4 is going to be a total of 5. So now when I look at my answer right here, I've just got, I can take that x to the 5th times 1, and I get x to the 5th all over 2. You can also leave it as 1/2 x to the 5th. That would also be a correct answer. So you could write it like this, x to the 5th all over 2, or you could write it like this, 1/2 x to the 5th. So now on our next exponential problem, dealing with our exponents, You're going to notice on number 16, it says we got 5 m to the third m to the negative 4. Then we've got times 6 m to the fourth m squared. So again, do your numbers separately. So I got 5 times 6, and 5 times 6 equals 30. Okay, now I'm going to deal with my m's. So here's my m. So remember the law is when you're multiplying those m's together, that's going to be 3 plus 4 because you got 3 m's being multiplied together times 4 m's being multiplied together. And so you're going to notice that that becomes m to the 3 plus 4, so that's going to become m to the 7th. Okay, now on this last one, we're going to go ahead and deal with our n's. So you deal with your variables separately, each variable to itself. So now notice again, I've got n, and I've got to the negative 4 plus 2. So following that rule, I take negative 4 plus 2, and I'm going to get an answer of negative 2. So when I get to that point right there, notice a 30 is going to stay in my numerator. M to the 7th stays in my numerator. But now to get rid of this negative 2, I just move it to the denominator. So that is, the answer is going to be 30, m to the 7th, n to the 2nd. Okay, now on the last set of problems, we're going to be dealing with our arithmetic and our geometric sequences. So remember your arithmetic sequence formula, and this is given to you on your test. The arithmetic sequence formula is a sub 1 plus n minus 1 times d. So remember this a sub 1 stands for your first term. N means the number of terms that you're going to be using, and d is the difference between the terms. So notice this right here, this 7 is my first term. So that is my first term. It wants me to find a sub 37, so that is the number of terms. So that is going to be your n. So there's your n. This is your first term, which is a sub 1. And now to go ahead and find your difference. So here's your difference formula. Your difference is the difference between your terms. Or in other words, what is happening when I go from 7 to 3? Well, if you look at that logically, you know that you're going to be subtracting 4 to go from 7 to 3. But if you want to, you can actually follow the formula, which just says take the second term minus the first term. Or in other words, take 3 minus 7 to find your difference. And when I take 3 minus 7, I'm going to get negative 4. So negative 4 is going to be my difference. I substitute in right here my 37 in place of the n. And then I'm going to put my 7 in place of the a sub 1. That's just actually just a matter of typing in your calculator exactly as you see it. So don't forget, just take your calculator, type in exactly as you see. You got 7 plus, and then we're just going to put in parentheses 37 minus 1, and end parentheses, and then just put parentheses around your negative 4. So whenever you're using your calculator, just type it in exactly as you see it. So when I type that in, you're going to notice that I get an answer of negative 137. If you want to do it out separately, that's perfectly fine. That's what I did right here. I took 37 minus 1, I got 36. I took 36 times negative 4, I got negative 144. I took 7 plus negative 144, and I got negative 137. So this last set of problems, just following your formulas. So again, we're just going to go ahead and substitute this in. But now this actually wants us to find a general formula. So all I have to do is I just have to find a sub 1 and my difference, and then just substitute it in. And then when I'm done, I'm going to go ahead and simplify my answer. So again, remember a sub 1 is this first term. So a sub 1 is equal to 2. My difference, well, if I can't see that going from 2 to 12, and I'm actually adding 10 there, I can take my second term minus my first term. My second term is 12 minus my first term, which is 2, and that difference is going to be 10. So now it's just a matter of substituting all that into the formula. So there's 2. I leave the n minus 1 in there because I'm looking for a formula. So don't forget, you're just finding the formula for it, and then substituting in that 10 for your difference. So once you've done that, all you have to do is just go ahead and use your distributive property to go ahead and simplify this down. So simplifying this using your distributive property, we've got 10n from that right there. And then when I take 10 times negative 1, that's going to be negative 10. Now that I've done that, all I have to do is just combine 2 minus 10, and I'm going to get negative 8, and the 10n stays the same. So my formula that I can use on any equation I want to is negative 8 plus 10n. Now number 19, now we're dealing with geometric sequences. So remember, geometric sequences are different than arithmetic sequences. Arithmetic sequences you're adding to get to the next term. Geometric sequence is when you are multiplying to get to the next term. But the formula will be given to you on your test. And the formula is just this: a sub 1 equals, or sorry, a sub n equals a sub 1 times r to the n minus 1. So remember, a sub 1 is going to be your first term. That r that you're going to be looking for is the ratio. And the ratio basically just means what number am I multiplying by to get to the next term. Sometimes you can look at your sequence and decide that just by looking at it. Other times you might have to find it. And then of course n is the term that you're looking for. So here's my a sub 1, which is 4. So if I can't see that that is being multiplied by 3, I can take 12 divided by 4, which is that opposite, and I can realize that my ratio is 3. And then the term that I'm looking for would be this term right here. I'm looking for the 8th term. Now it's just actually a matter of substituting it in and solving it. So remember, my first term, if you look back up here, was 4. So since that is 4, I'm just going to substitute that in down here. And when I substitute that down in here, I get 4 in terms of a sub 1. And then here's my ratio right here, which is 3. And then the 10th, and I'm looking for my 8th term. So substitute that in, and I got 8 minus 1. Now when you're done, if you just type that in exactly in your calculator, you see it, you'll get the right answer. Just type in 4, put parentheses around your 3, hit your power key, and then type in 8 minus 1. Hit enter, and there's your answer of 8,748. So now this last problem here, we just want to find a formula that represents this sequence. So notice it says on number 20, you're going to go ahead and find the explicit formula using the given equation below. So notice again, we're following our geometric formula right here. All we have to do in this case is just find a sub 1 and the ratio. And when I substitute in, I don't even simplify it. Because remember, your order of operations say you got to do powers first. So you just leave it. So here's my a sub 1 right here, which is 3. I substitute that in for my first term. I find my ratio. If I don't recognize this is going up by 2, I can take 6 divided by 3, which is 2, substitute that in, and then I still have my n minus 1. Now remember, I cannot take the 3 times 2 because my order of operations say I have to do powers first. So that is my answer right there. I'm done. It's that straightforward. Just substitute it in, and you're finished with it.